All right, so today is simplifying and evaluating. This is day 12. So we're going to start by simplifying. And again, some of these hopefully you've seen before. So problem type A is where you're going to find the product. And the word product is the result of multiplication. So when you multiply, you get a product. All right, so we are going to multiply negative 15 times negative 1 over 25. Now, one of the things you have to remember in math is there's lots of invisible things that are there that we just don't write because we try to keep our work as easy as possible, mathematicians being lazy. So whenever you see a whole number, you have to already know that that whole number is actually over an invisible 1. And the reason that you need to know that is when you're multiplying, you can only multiply the top with the top, the numerator with the numerator. You multiply those together, and then you multiply the bottoms together, denominator times denominator. So that's where knowing those invisible ones pushes that negative 15 up to where it needs to be, which is in the top. So doing this, a negative times a negative is a positive. 15 times 1 is 15. On the bottom, 1 times 25 is 25. Now, both of these numbers end in a 5, which means they can be reduced. Let's revisit prime factorization as a way to reduce. You give two numbers that multiply to give you 15. That would be 3 times 5. And two numbers that multiply to give you 25. That would be 5 times 5. And then any factors they have in common divide to 1. And what's left is your reduced fraction, which is 3 over 5. Again, this is something you will need to do without a calculator on a pencil paper test. All right, let's do number 2. Absolute value with negative 2 cubed times x squared. All right, so what you need to know in your mental library is that absolute value bars are grouping symbols, which means you do everything inside first, and then you go outside and get rid of it. So inside the grouping symbols, we do exponents, left to right. So I have negative 2 cubed, which is negative 2 times negative 2 times negative 2. And then I have an x squared, which means there's 2 x's. So that is really what's going on. When you multiply several numbers together, you go left to right and you do them in pairs. So you do negative 2 times negative 2 first. That gives you a positive 4. And then I'm just going to recopy the right. Keep going to the right. 4 times negative 2 is negative 8. And then x times x is just x squared. So there's not much to do with that. And then now we're going to get into something we didn't do before. Yes. So x squared is what we call an even power. It's a 2. And when you square something, it's either a negative number times a negative number, or it's a positive number times a positive number. The thing about even powers is when you multiply those negatives or those positives, in both cases, you get a positive value, which means we can take the 8 out because all numbers come out positive, but it also means we can take the x squared out. It's not trapped in the absolute value. And we're taking it out because it's x to the power of 2. It's an even power. So what happens with an odd power? Let's say you've got the absolute value of negative x cubed. That's an odd power. Okay, for starters, that negative is not being cubed. So remember that when the negative is not in parentheses, it's like a -1 times an x cubed. And a absolute value of a -1 is a +1. So it comes out of the absolute value. All right, so now we're kind of where we were with the last one, but we have an x to an odd power. So with x being to an odd power, 3 of them, we could have, if we knew what x was, it would be a negative times a negative times a negative, because you'd have 3 negative x's multiplied, or a positive times a positive times a positive. We just don't know which one it is. And the reason this causes a problem is that a negative times a negative times a negative is a negative, but a positive times a positive times a positive is a positive. On the last one, they both came out positive, so we could pull it out of the bars. In this case, we don't actually know what x is. So big question mark on that. So the x has to stay inside the absolute value bars. We simplified the negative out, the -1 out, but the x cubed is trapped because we don't know what it was originally. So even in odd powers do cause some dilemmas. This is the first time we've come across it. All right, so we're still on simplifying. So we're going to go to part B, which is variable multiplication. We've done a little bit with this already, so this part should be familiar. All right, -3 times -x times -x. All right, the trick to multiplying these negative x's is to realize that the x isn't negative. The negative is being multiplied by the x. So this is actually a -3. And then this -x is a -1 times x. So is that one, a -1 times x. Now, again, did we write the ones to begin with? No, there's lots of invisible things in algebra that you have to learn are there, whether they're obvious or not. These -1s are there. And what that allows us to do is push all the numbers to the front. So I'm going to push both -1s to the front and then leave the x's for the end. So you pull the negatives off the x's, turn them into -1 factors, and then now we're going to multiply like we did on number 2 up above, left to right. -3 times -1 is +3. Bring everything down. Continue to the right. 3 times a -1 is a -3. And then I have xx, which is just x squared. So if you have a negative variable, you got to pull the negative off of it. All right, let's do another one like this. -2x times 3x. This one, we don't have to put in any invisible numbers because the negative is attached to the 2. So again, we're going to push the -2 to the front, the 3 to the front, and the x's go at the end. And then you just multiply the numbers. -2 times 3 is -6, and then xx is x squared. So we only have to worry about the -1s when there isn't a number on the variable, and the variable itself is negative. That means there's an invisible -1. Okay, any questions about this?
Are we doing more?
Yes. So now we're going to go to evaluating.
Am I right on the back side?
Mhm.
You have to get a new one.
No, you can write on the back. I can't because my pen bleeds through. All right, evaluating. The word evaluate tells you what you're supposed to do in the word. Evaluate is to get a value, which is to get a number. So what you're going to do when it says to evaluate is you're going to replace x with a number, and then you're going to simplify. And in the end, your answer is going to be a number because you've replaced all the x's with numbers. So all the x's are gone. So when you evaluate, your answer should automatically be a value or a number. Again, evaluate. That, if you just think about that word, it tells you exactly what you need to do. All right, we are going to evaluate x cubed minus 2 when x equals negative 2. Sometimes they'll say when, sometimes they'll say if, sometimes they'll just do like x cubed minus 2 and they'll do like a semicolon and then they'll have x equals negative. That just splits the two pieces. It doesn't mean anything mathematically. So, but they all mean the same thing. This is what you replace. So to evaluate, we're going to replace the x with a negative 2. Now, because the x is being cubed, the negative and the 2 are being cubed, you're going to need your parentheses. Negative 2 cubed, because you want the negative and the 2 to be cubed. Okay, so now we're back to order of operations. This is old stuff. Exponents first. So negative 2 cubed is negative 2 times negative 2 times negative 2. I'll just bring down the minus 2. So we're going to multiply from left to right. So negative 2 times negative 2 is a positive 4. Recopy the rest. Keep going to the right. 4 times negative 2 is negative 8. We're done multiplying. Now we do add, subtract from left to right. Negative 8 minus 2 is negative 10. So really, you just got to sub the number in, use parentheses if you need it, and then it's exactly what we've been practicing for the last week. All right, last problem. Absolute value of negative 4 times t minus 5 if t equals negative 1. You'll notice I put little tails on my t's. That's just a handy little tool because it makes them not look like pluses. And if they look like pluses, it messes with your algebra brain. Algebra is visual. If it looks like a plus, you're going to think it's a plus. So this is another evaluate. So we're going to substitute in negative 1 for t. So here we go. Absolute value, negative 4, and then in parentheses. Now, this t doesn't have a number in front of it. It doesn't have a power. So we can just put the negative 1 in without parentheses because there really isn't anything being done to the t that we have to use parentheses for. Okay, so now we've subbed in. Now, order of operations, you go to the most inside pair of grouping symbols. So absolute value bars are grouping symbols, but you're going to go to the ones inside that, which is here in the parentheses. You're going to do that first because it's inside the parentheses. So negative 1 minus 5 is negative 6. Recopy the rest of the problem. So we've done the parentheses. Now we go to exponents, none. And we're still inside the bars. Then we go to multiply, divide. Aha, here we go. Negative 4 times negative 6 is positive 24. Now that everything is simplified, a positive 24 comes out to be, or absolute value positive 24 comes out to be just 24. Everything that comes out of absolute value is positive unless you're talking x's and stuff like that.
Plus